Hi, everybody. I'm Kyle Ellicott, and here today I'm joined with the founder and CEO of ThreeFold. Kristof, welcome. Can you provide everyone a little introduction about yourself?
Thank you, Kyle, for inviting me to this conversation. So yes, indeed, I'm Kristof. I like to call myself a nerd engineer, coding since I'm 8 or 9, and I'm very passionate about the internet. Since young age, when I came out of university, the internet was just starting, and I loved that feeling of people connecting cables and exchanging information with each other, and that gave me a lot of passion. And that's why still today, most of what I do is around that, which is how can we give people back their internet? Not the current one, which is very centralized, but a new internet, just like before, where in a free way, we can all sort of exchange information, connect the cables to each other, and build this new version of an internet, which is based on trusting each other, which is based on making friends, let's say. So let's go back to the past. That's my passion.
I love it. So let's go back to the past for a moment. You started ThreeFold. You brought this out of passion. You're talking about this decentralized internet. Let's first answer the question. What is the decentralized internet? And then let's go back in time as to why that's important. But talk to us about what the decentralized internet is.
Yeah, so today the internet is way more centralized than people realize. You have these big, what they call data centers, which are these big buildings with sometimes millions of servers, computers, and they basically have our data, they have our applications. And anything we do today, because internet became such an important thing of our life, but whenever we do something, we basically travel to a data center somewhere very far away, and then we travel back to where we're coming from. And if we communicate, it always goes over these big monster data centers. And that makes the internet very centralized. Actually, less than 20 companies in the world own more than 80% of what we call the internet capacity. And that's, of course, insane. And it has many other downsides to do with how do we know the information is true? How do we make sure we're not becoming a product? Because that's often the case today. And that is a very centralized way how to look at the internet. But most people don't even realize. They just look at their phone and they see an application, and that for them is the internet. So we need to go back to a different type of internet where we can all participate, where a little bit like what a solar panel does for electricity, it's kind of a similar thing. So you can, rather than taking your electricity from a nuclear plant in your country, you can put a solar panel on your roof and you can generate electricity for the people around you. And we did exactly the same thing, but then not for electricity. We did that for what we call internet capacity, which is compute, storage, network capacity. So we can basically just buy any computer. It doesn't really matter what it is. We download this piece of software we have, and now this box becomes part of this global grid of compute and storage capacity, and it delivers that to our friends, to the people around us, like the old days, really. And that way, we become the internet. That's why we call this like be the internet. So we become the internet. We are the internet, or we give that internet to the people around us. And then whoever wants to can build things on top of this. So anything which runs on standard computers can run on top of this. So people can use this to deploy their own applications for the people around them. So you don't have to use these centralized locations anymore. And this allows us to be more free again, and it's much faster and it's more green. So it had lots of benefits. So that's what we call decentralized internet. It's actually more than decentralized. We like to call it peer-to-peer internet. It's like I give internet to my neighbors who can give it to their neighbors. So it's like we give it to each other and it stays local to us. That's what we see.
Yeah, and you mentioned a box. Is there an actual device that users are going to be using in this new version of the decentralized internet that you and ThreeFold are building, or is it something bigger than that as well?
Well, it has the two sides. So just like the solar panel on your roof, if you put enough solar panel on your roof, the people around you don't have to do that, right? Because they, in theory at least, are able to use your electricity. It's a similar thing here. So some people choose to provide to this new internet, so they can buy a box. And a box can literally be $500, or it could be $50,000. Okay, I wouldn't put that in my home, but still, it could be a big box.
It could be.
It could be, or you can put it in a data center still. It's not like that you can't do that. You can do that. And actually a lot of people did do that. So put it in a data center to have more connectivity. But either way, you become then what we call a farmer. So you buy this box, any computer will do actually. And you will be rewarded for keeping that box connected to the internet, the current internet, okay? And all of these boxes will communicate to each other, looking for the show. We use the existing links, the existing internet network connectivity to make these connections. And that's one side of the puzzle. And now at the other side of the puzzle, you have people who want to use this new capacity of this internet. You could be a developer, or you have an application, or you're just an end user, and you would just be using it, right? And for that, you need to use that same, we have this token called ThreeFold token. So you need to use this token to use that capacity on that grid, and you become a user. So you don't need a box yourself. You can use a box of people around you, or anyone can host that for you actually. And that way you have a real ecosystem of people providing capacity and other people just using capacity. And maybe you're an end user, you don't even realize that you're running on this new internet. You just go to an application, but the application is hosted on this new internet, and then you wouldn't even know.
And speaking of applications, you mentioned that people could be building or running applications on this decentralized internet. What are some of the use cases of applications that we might see, or that you're excited about seeing applied in this vision?
Well, anything which runs on what we call Linux, which is an open source operating system, can run on our grids today. So that basically means that, to put it in more human-friendly terms, anything to do with blockchain or old web or new web or decentralized web or whatever they call it these days can run on this missing layer. We call ourselves like a missing layer. So we are like an infrastructure layer for everyone else to build on top of. And it's very generic, it's very open. So you can pretty much run anything on top of it. And we have a network part, we have a compute part, and we have a storage part. And you can combine those to basically become whatever you need for your application. So on top of this, well, that could be a blockchain, or it could be a social media app, or it could be your website, or it could be a very complicated, I don't know, even a banking app or so. That can all run on the same infrastructure. It doesn't really matter. It's really up to the community to choose, rather than putting it somewhere centralized far away from where the users are, to let this run on our grid much closer to where the users are, and that way be more green, faster, more secure, and all of that. But actually pretty much everything can run on top of it.
So I want to come and pick apart the security aspect. So previously you and I were speaking a little bit about the storage component before we jumped on today, and I would love for the audience to hear what is happening at ThreeFold around storage, because you do something more than distributed storage. You go a little bit further into the near future. There's something that is protective of what we all need as this decentralized internet evolves in front of us, and that is quantum safe storage. Now that's a lot all in one. Can you break down what this decentralized storage and how quantum and quantum safe all applies to it?
Yeah, sure. Well, look, we are since 2000 or even earlier, actually, looking into data centers and cloud and internet, and storage is like the main thing to resolve, because if you resolve storage, I mean, that's where our data is, right? You never want to lose it. It needs to be fast enough. It needs to be close to where you are. So storage is like the thing you need to resolve if you want to do something like we do. So a big part of the last 30 years, we have been, thinking about storage and trying new things out. And about, what is it now? I think 14 years ago, that was another iteration. We were like, wow, they were using something in space, and it's called forward-looking error correcting codes. Yeah, that's kind of a mouthful. And we were like, oh, that's a very cool idea. And basically what is it? It's like, if you send a package of data from here to the moon, and imagine there is some corruption under the way, right?
Yeah.
You don't want to have to resend that data, because you would have to wait a long time again, right? Because it takes a time before information comes from Earth to the moon. So they invented a protocol for that, a sort of error correcting codes, forward-looking error correcting codes, hence the name. So we were like, damn, that's a really cool idea. Why can't we use that concept for storage, right? Because there's some And I don't want to go too deep into detail, but there are some very cool properties of how to do that. So we tried to apply this onto storage about, what is it now, 14 years ago in the first iteration. And we got to very good results. Now we got help from Intel and some other smart people, because in the beginning it was way too slow. But now it became like fast, it's now generic available. And how can you think about it? It's like, rather than storing information in one location or making copies, that's what normally happens, like on a blockchain or in a normal storage system, you will make copies, right? You will say, okay, if I don't want to lose my data, I need to make sure I have enough copies so that I can always find it back and restore it. But there are many issues with that. It makes it, well, first of all, unsafe, because you can only use encryption or something else to keep it close to you. But there is a lot of leakage of information if you do that. So, and it's also a lot of overhead. If you want to be able to lose 4 locations, you will need 5 copies. So there's a lot of overhead, right? So our system more works like the Sudoku puzzle. You know, Sudoku with all, you have to put these little things together. And if you have enough of them, you can get to the original. Yeah. Well, that's how we created this. So as long as you have enough pieces, the puzzle is smart enough, the computer is smart enough to figure out which pieces we need. And if we have enough of them, the puzzle makes sense and we come back to the original, right? And that's what we did. So this allows a user to store data. Well, they don't even see it, but underneath, the data goes to locations they can choose, right? So they have full control over where the data goes. But it's stored in such a way that, imagine we do it over 20 locations. You would need to be able to even physically get back to the data. You would have to be physically in 16 locations of the 20. You would have to know the encryption key. You would need to have access to that data, and you would have to understand the algorithm. So we think that's pretty much impossible. And that's why we call it quantum safe, because a quantum computer, even how smart as it can be, it simply doesn't have enough information to work with, right? So it can never put a puzzle together because the information is simply not there to work on. And that's why we call it quantum safe. So it's not quantum storage, it's quantum safe. So that basically means not even a quantum computer can hack it. The moment it's stored, you are guaranteed the only person who can get to it. It doesn't get replicated, so it's not copied. It's stored, you have complete control over where it's stored. It's still very efficient, it's still very fast. It can never get corrupted ever. Even if a disk would have some issues or it would automatically get recovered, you wouldn't even see it. And all of that is now working for a couple of years. So that's this quantum safe storage.
Wow. So this is, I mean, a decade plus in development. It's now been working for a couple of years. What has been the feedback? What's been the response? Are people excited about this? Are you seeing applications leveraging this?
Well, the first iteration was done, what is it now, 10 years ago. And that company got acquired actually by HEST, and still there today, you can buy it. Even some, well, I can't mention names, but let's say some big sensitive security organizations, let's call it that way, were for sure using that storage system. So at that time, it was very successful. And that's also why that company got acquired. Of course, we recreated a new version, a new code, and wherever you always learn, right? As we go on, we can make it better. But the first version was active more than 10 years ago. About 4 years ago in this iteration, we got it to work in Switzerland. And there, together with a partner, we have 50 petabyte in Switzerland, which is a lot of storage, actually, running there for years to prove the concept. And it's like a self-healing system, so we don't touch it, it just runs. And that was, yeah, thanks to our partner, an amazing way for us to get more experience and to show it to people and so on. So it's not very new, which is important for a storage system, but it allowed us to keep on improving, making it faster, put new interfaces on top to come, yeah, now where we are today, so they can become like a backbone or an underlying system for everything else we do.
Wow. So with all this time, what are some of those learnings otherwise that you've seen in developing ThreeFold to where it is now? And you guys have a great, exciting announcement that we're going to talk about in just a moment. But with all these pieces and these building blocks coming too, and we went from a decentralized internet to a centralized internet, now are finding ourselves back in this decentralized world. What are some other learnings that you and the team have seen and are putting together now in new products?
Yeah, so much, right? I think this idea started about 10 years ago. And, it's not like 10 years ago we knew what we're doing. Let's be no, we had an idea where we wanted to end up with, but it was trial and error and trying multiple things. So about 5 years ago or so, we realized that we had to rebuild an operating system. And then a lot of people were like, Kristof, you're out of your mind. You're not going to rebuild an operating system, right? That's just too crazy. And I said, yeah, but we kind of have no choice because we need to be close to the hardware. It needs to be more efficient. And because that's the problem with IT today, it's so complicated. There are so many layers, right? Look at virtualization, software-defined networking, storage, for so many layers. And that introduces a lot of loss of energy, but also complexity goes up, so security is less. So about 4 or 5 years ago, we kind of jumped into the pool, let's say, and say, okay, you know what? Let's pretty much rebuild everything from scratch. So we took a Linux kernel and we started building this new operating system. And that was a hard undertaking. And rethinking, it became a minimalistic operating system, right? So it's like, how can we make sure that people can build their things on top of this operating system? The operating system itself is controlled by blockchain, but it's not blockchain, okay? It has these primitives inside about storage and networking and so on, like the storage system I was talking about. Yep. And there's no shell. There is no server interface. So it's a very safe operating system, very close to the hardware, which makes it possible what we did. And that was another major breakthrough, which we had to do. And it's now 3rd generation. So it took us some time to get there. But that was a major one, really learning from. But you know, the funny part is at that time, we thought, wow, it's going to be so complicated. But as we went forward and we realized the closer we were to hardware, actually became easier because there were less things to think about. So after a while, we started having enough primitives and our life became easier and we could go far and we could make progress faster. So this was an important element, but now it's there. So people can download it, they can install it, they can play with it. So that's finished.
Very cool. And speaking of people being able to interact, you just had a big announcement around neighborhood networks and bringing essentially what you just mentioned, the decentralized internet or decentralized cloud in some cases, to a neighborhood in Dubai.
Yeah.
This was a big headline announcement earlier this week. Can you share a little bit more about that project and what it means for that neighborhood and potentially the future neighborhoods?
Yeah, that's an amazing project. And we need to thank the people from Paradise Hills because that's the name of that project. Look, in Dubai, yeah, there's not that much. Why? There is actually a lot of data center capacity, but they're running out of it because that area is growing a lot, actually. And yeah, one way could be that, you know what, let's keep on building data centers. But what we are doing now with this developer of real estate is that we say, look, why don't we give every home which is being sold into the neighborhood some data center capacity? So basically, some compute and storage network capacity goes in each home as part of the project. And now there are about 170 homes. And now all these homes together, right, they're interconnected into that area. They now become like a distributed data center. So it's like a true decentralized data center, if you want, where the storage and the compute is distributed over these homes, but in such a way that the data can never get corrupted nor lost. And all the people now become the providers of capacity for this new type of sort of distributed data center capacity or internet capacity. So now governments or anyone in that area who wants to have storage or more compute, they can of course go to the data centers, but they can also get it from that compound, from where all these homes are, right? And it's amazing because cost-wise, it's amazing. Security-wise, it's incredible, actually. It's super reliable because of the things we just talked about. And this is like a win-win-win, right? It's a win for our partner company who is doing the homes, because it's kind of a very nice way how to reward the people buying a home. They become part of this new internet. They also have a financial reward out of it. It's a benefit for the planet. We're not burning energy. We don't have to build a data center. It's more reliable. Data stays inside the country. And it's a benefit for Dubai in this case, because they have more access to data center capacity without having to build a data center. So it's an amazing example of how we can build out internet capacity without having to build data centers.
I love it. And I got one more big question for you, and it's a teaser to what else we're going to be talking about soon: farming. There's a huge initiative in the ThreeFold community and also all over on the website about farming. Can you talk to us and tease us a little bit about how that plays a role into the bigger ecosystem? And we don't need to get too technical and break it down because we're going to, but just give us a little teaser.
Well, what in a normal crypto project you would call mining, which basically means you are contributing to a digital currency or crypto project. We called it farming because we didn't want to have the connotation with burning energy, right? So what is farming? It's basically anyone who wants to extend that internet can buy a computer, connect the computer, any computer will do. You just connect the computer to the existing internet, and now you provide compute and storage capacity to your friends, right? And that process we call farming. And you as a farmer get a benefit in the form of these threefold tokens, which is our own currency. So when you farm every month as a sort of reward for the capacity you have contributed, you're being rewarded in the form of these tokens. And now people who want to use that capacity, they need to buy those tokens. And that way we have an ecosystem where farmers produce capacity as such, get tokens rewarded, and then people who need the capacity need to buy those tokens so they can use the capacity you're farming. That's kind of the ecosystem.
Perfect. We are going to go deeper on this subject, but that's a perfect teaser. Thank you, Kristof. Anything else that you would like the world to know a little bit about where ThreeFold is today and where you're going? And then we'll wrap up here as well.
Well, look, ThreeFold is at a very interesting period right now. If people look outside what's happening, like in Ukraine and the rest of the world, I think more and more people start realizing that internet is so important to us that we need a more decentralized version of it, a peer-to-peer version. Blockchain alone is not enough. And right now, our project is only starting, right? It's interesting, it's starting, and we need everyone's help to make this happen. So whoever wants to extend it, or maybe you want to buy the token, or you want to learn more about it, we can really use your help. This is a community project. It's not about us. We call it like be the internet. It's about we together now need to create this internet so we can have something more reliable. You can have it close to you and you can become part of this internet, right? And this is happening now. So we need like many people to want to do it. You know, we go back to the beginning of the internet. We build it again.
I love it. Going from 1.0, 2.0 to 3.0, all the way back to 1.0 in the evolved version that it is. Kristof,
thank you.
Yeah, thank you so much to everyone tuning in today. Thank you as well. To learn more about ThreeFold, check them out at threefold.io to learn more about what Kristof and I just spoke about, also around farming and a few other areas that we discussed in the future of the decentralized internet. Definitely check it out. Definitely start building. There's some exciting stuff we'll be talking about in the coming weeks as well with Kristof and the rest of the ThreeFold team. So stay tuned. Kristof, again, thank you very much. Everyone have a great day. I'm your host, Kyle Ellicott. And until next time, take care.